All right, we can use an equilibrium constant to predict the direction of a reaction. Because, guys, just because we have a reaction written that might be at equilibrium, we don't necessarily know if that reaction is moving forwards or it's moving backwards. Well, what do you mean by forwards or backwards? Well, for this example, hydrogen gas plus iodine gas in equilibrium to make hydrogen iodide. And that's the balanced equation for that reaction. When I say things like, is it moving forward or is it moving backwards, I mean according to how it's written. If it were moving forward, that means it's making more HI. Because just because you mix chemicals, it takes time to reach equilibrium, right? It's not an instantaneous equilibrium. It takes a little bit of time. So once they hit equilibrium, then the amounts of products and reactants, that's going to be equal to an equilibrium constant. But what we can do is calculate something called a Q. Q is known as a reaction quotient. How is Q calculated? It's calculated just like an equilibrium constant. In other words, to calculate Q, I would take the products divided by the reactants raised to the power of the coefficients. So it's calculated exactly like you would calculate a KEQ. Okay? If it's just like a KEQ, well, how is it different? Because KEQs have to be calculated at equilibrium. Qs do not have to be calculated at equilibrium. You can calculate them at any point in the reaction, and by comparing Q to the KEQ, you can tell which direction the reaction is moving. Is it still going forward or is it still going backwards? When Q is less than the KEQ, that would tell me the reaction is moving forward. And so if I were interested in producing HI and I saw this, that I'm not to equilibrium yet, I'm still making HI, then I wouldn't want to stop that reaction because I'm still making product. But what if I measure it and I see that Q is larger than the KEQ? If Q is larger than the KEQ, what does that mean? That reaction is moving backwards. And so if producing HI is what I'm interested in and I realize, oh my goodness, the reaction is moving backwards, that means my HI is breaking down. That means I need to stop that reaction and harvest the product that I want because I'm losing money. What if the Q is equal to the KEQ? It means it's at equilibrium. It's not moving forwards or backwards. Okay, so using this equation of hydrogen plus iodine yields HI.
What was it if it was equal?
It's at equilibrium. Okay? The Kc for the above equation is 78. At, I don't know, 300 Kelvin. A sample is analyzed Okay, for this one, I know that Kc for this equation is 78. If I'm asked about a direction for a reaction, then I'm going to have to calculate a Q. How do I calculate Q? I plug in the concentrations and I do products over reactants raised to the power of the coefficient. So Q then would be equal to what? 1.98 squared divided by 0.243 times 0.146. What do y'all calculate for Q? 110.5, so 111 for Q. Agreed? All right, Q is 111. The equilibrium constant is 78. Yes, since Q is larger than the KEQ, the reaction is in reverse. It's going backwards. How far backwards is it going to go? Well, it's going to go backwards until the equilibrium constant is 78, and then it's going to stop, but I'm losing product at this point. So the answer is the reaction is moving backwards.